Hey everybody, I'm Andrew and welcome to episode 2 of the Dawn of Sapiens podcast. I've recently been working on a YouTube video for my Dawn of Sapiens channel, and this video is over Homo erectus and out of Africa migrations. And there's 3 or 4 studies that I read for this video that I probably won't end up using for the video, but I keep thinking about them and I find these studies interesting, because they kind of touch and hint at the differences between quote-unquote modern humans and our ancestors like Homo erectus. The first study that was led by evolutionary anthropologist Gary T. Schwartz out of Arizona State University is entitled Growth, Development, and Life History Throughout the Evolution of Homo. The main section that caught my eye was the section where he's talking about the M1 emergence, or the first molar emergence. In this study, they're kind of talking about how researchers have been able to associate the time or the period whenever this adult molar first erupts out of the gum line, and they've been able to associate that time period with other biological developmental functions such as brain size and other life history milestones. And the takeaway from that is, if they can apply this knowledge to the fossil, they can pinpoint the developmental stage and ultimately the age when this individual from the fossil remain died. It's still a little guesswork. The best way that scientists can kind of determine this is by comparing it to animals that are alive today. And when it comes to bipedal or hominin species, you can have the two extremes. You have on one hand living humans today, and on the other hand chimps. And for example, chimps on average, their first molar erupts from their gum at about 4 years old. And for humans, that's at about, on average, 6 years old. And I guess I should back up and kind of point out that what we're really talking about here is whenever a 5 and 6 year old kid loses their milk teeth or their first teeth, and the tooth fairy pops up and gives the kid the dollar. And it's this point in our life history that we're talking about, where the tooth is lost and then the adult first molar makes its first appearance. So keep those two numbers in mind. At 4 years, chimps' first molar appears, and in humans, on average, it's at 6 years old. But here's the real interesting part. When they look at early Homo erectus fossils, they find that on average, their first molars appear at around 4.5 years old. This is actually kind of striking to read and to even just think about. Homo erectus is often called the first human. It's one of the first species to really have something close to the modern human body shape and body type. Long legs, short arms. And if you've come across Daniel Lieberman's work, they're even thought to be the first long-distance runners. So there's so much that's human about Homo erectus, and yet in some ways it appears that their life history is much closer to chimpanzees than to humans. This is telling us that at least some developmental stages are shorter in Homo erectus than in modern humans, which isn't a huge surprise when you consider the brain size difference. Some of what we call Homo erectus, early Homo erectus individuals have brain sizes that are as small as 600 cubic centimeters. There is a couple other interesting points made in this paper, or at least pieces of data. They're showing that Neanderthal first molar appearance is 6.7 years, which is 0.7 years later than in humans, in Homo sapiens. So this in a way is indicating that Homo neanderthalensis had actually longer life stages than Homo sapiens. I haven't really thought about the implications of this enough to really talk about it so much. I'm going to have to think about that a little more. But and then on the other end of the spectrum, there was something else that's probably even more interesting to me. According to Schwartz and his team, they showed that M1 emergence was sooner in Australopiths than even in chimpanzees. And that's surprising. I mean, at least to me it is. This is kind of a head scratcher, but in that same study, they pointed out that, quote, highly terrestrial species possess more accelerated life history schedules than non-terrestrial species, likely as a result of increased intrinsic mortality in the form of predation. So that's really interesting to me. It really makes you wonder if the difference of 4 years of age at first emergence versus 3.1 years of age in Australopiths, is that a signal of higher predation as our ancestors and our lineage left the trees for good and became more vulnerable to predators? Again, I haven't really considered this long enough or done any research into it, but that's something to think about for the future. It's interesting, at the very least. This second study is by anthropologists Mark Meyer and Martin Hausler. It's a 2015 paper entitled Spinal Cord Evolution in Early Homo, out of the Journal of Human Evolution. And in this paper, they're analyzing the fossil remains of two different Homo erectus individuals. One of them is individual D2700 out of Dmanisi, Georgia, in the Near East. And the second is KNM-WT15000, which is also known as Turkana boy, out of Kenya, Africa. And they're basically comparing the spinal canal size of these two individuals with the spinal canal sizes of modern humans, and to see if they fit within the spectrum of modern human variation. And they found that they actually did have spinal canal sizes that fall within the modern human spectrum. I like the way they put it in the paper. They basically said a fully human spinal cord, but with the brain half the size of a modern human. And while I was reading this, I couldn't help but think about the paper that I first described, where you have this species that has, on the one hand, an abbreviated life history, and on the other hand, a fully human spinal cord. You would think that with abbreviated development, nothing would be full size. I mean, as they put it, even the brain wasn't full size. And that's what you would expect with a shorter life history, basically a shorter life. But on top of that, the next question becomes, what's the benefits of having a larger spinal cord? And in this paper, the researchers point out that an enlarged spinal cord increases the amount of nerves that can be terminated and interconnected with the spinal cord. The authors of this paper argue that it's the abdominal wall muscles, and the result is that Homo erectus had better breathing coordination. And in this study, they identified several sensory circuits whose inputs are actually processed by the spinal cord itself. The sensory inputs of these circuits are touch and vibration. So here you have a species that has increased capacity for breathing control, along with a species that has higher sensitivity to touch and vibrations. To me, this means that Homo erectus probably evolved a capacity for higher intensity bipedal locomotion or running. But when you step back and you think about these traits and qualities of Homo erectus, or at least early Homo erectus, it makes you wonder how different were they from us, and how much would we recognize ourselves in them? What does it mean to have an abbreviated life history, to grow up faster, to have half of our brain but all of our spinal cord? One point that Schwartz et al. Made was that even modern humans have a wide variety of morphology and developmental stages. But I don't know how much that can apply here, because when you read about, for example, African pygmies, their developmental stages all the way to puberty are basically identical to everybody else's. The difference is they stop growing when they reach puberty. So their childhood development is as human as yours or mine. But it's this exact period where you see the difference from Homo erectus, or from chimpanzees, or Australopithecines. And even in Homo erectus itself, there's wide morphological variation. I mean, even these two individuals themselves are on opposite ends of the spectrum. D2700 from Georgia is estimated to have been about 4 foot 9 inches, or 145 centimeters tall, and would have had an adult brain capacity of somewhere around 700 or 750 cubic centimeters. Whereas Turkana boy from Kenya had about a 909 cubic centimeter cranial capacity and was about 5 foot 9 inches or 175 centimeters tall. So even within these two specimens, there's wide morphological variation. But those patterns held for both of them. They both had fully human, quote-unquote human, spinal cords. but they each had considerably smaller brains than modern humans today. And each of them appear to have the same pattern of first molar eruption at 4.5 years of age. So just like humans, Homo erectus had wide morphological variation within the species, and yet they still seem to follow their own unique developmental pathways that are distinct from humans. You often hear people wonder whether they would be able to recognize Neanderthal if one was walking down the street or riding on the subway. But I sometimes wonder what it would be like to meet Homo erectus face to face. How different would they be? How similar would they be? There's obvious known differences. They have smaller brains. They have more robust skeletons, large brow ridges. But at the same time, some things we don't know. We don't know if they were hairless. We don't know where in our lineage hair loss occurred. We don't know if they could speak, if they had language. We don't know if they could think symbolically, and therefore we don't know if we could communicate with them. And yet, researchers have picked up faint signals in what they call archaic introgression in the genomes of modern-day Africans. And if I remember correctly, this is supposed to have come from a species that split from us about 1 million years ago or more. So it seems that even though I'll never have the opportunity to meet a Homo erectus individual face to face, some lucky human did, and it also seems like that person got lucky. Thanks for listening. I'll put links to all the studies I talked about in the show notes.